Welcome back to AI.Code.Cast. Today, we're going to be taking a deep dive into a problem that, well, it really highlights teamwork and how important it can be.
Oh, this sounds interesting.
So imagine you're, leading this software project,
Yeah.
and you've got this, amazing group of engineers.
Right.
But, and here's the thing, each one has, their own unique speed and efficiency.
Ah, I see. So it's not just a simple matter of picking the fastest ones.
Exactly. The challenge is to put together, the ultimate team, the coding A team.
To get the maximum performance, right?
Yes. But of course, there's a twist. There's a limit on how many people you can have on the team. And performance, it's not just about, individual coding speed.
Right, right. So how do we factor in those different speeds and efficiencies? What's the magic formula?
Well, that's where things get interesting.
I'm all ears.
Each engineer has a speed rating, like how fast they can code, and an efficiency rating, which is more about, the quality of their work.
Makes sense. So a super fast coder who writes buggy code might not be the best asset.
Exactly. And here's the key. A team's overall performance. It's calculated by taking the sum of all the team member speeds and multiplying that by the minimum efficiency of anyone on the team.
Whoa, okay, so it's like the weakest link analogy, right? Even if you have a bunch of super efficient coders, one person with a low efficiency can drag the whole team down.
You got it. It's a pretty harsh reality, but it really emphasizes balance and synergy in a team, right?
Absolutely. It's fascinating how this coding problem mirrors real-world team dynamics. You can't just focus on individual brilliance, it's the collective performance that matters.
Totally. And now we've got to figure out, the best way to actually find this optimal team composition, given all these constraints.
From a coding perspective, this is where it gets really interesting. How do we sift through all the possible team combinations without drowning in a sea of possibilities?
Yeah, I mean, if I were to try every single team combination, wouldn't that take, forever? Especially with a large pool of engineers.
You're hitting on a classic approach, the brute force method, and you're right. It quickly becomes computationally very impractical.
So brute force is out. What's a more, elegant and efficient way to do this? I'm guessing we need some fancy algorithms and data structures.
You're on the right track. There's a very cool solution using what's called a greedy strategy, and we'll combine that with the power of something called a priority queue.
Okay, well, let's slow down for a sec, just to make sure we're all on the same page. Can you give us a quick rundown of what those are? Greedy algorithms and priority queues.
Absolutely. Okay, so imagine you're at a buffet.
Dessert buffet.
Always a dessert buffet. And a greedy algorithm, it's kind of like that person who just grabs the most delicious looking treat at each step without thinking about the bigger picture.
So it's all about making the best choice in the moment, even if it leads to a sugar crash later.
Exactly. They're not always perfect. These greedy algorithms, they don't always guarantee you the absolute best solution. But they can be incredibly efficient, especially for problems like ours. Now, a priority queue, it's like a line where, the most important person always gets to go first, no matter when they got there.
Ah, so if we were prioritizing by, efficiency,
Yeah.
the most efficient engineer would be at the front of the line.
Precisely. And there are different types of priority queues. For this problem, we're going to use what's called a min-heap priority queue, which basically means that the engineer with the smallest value, the slowest one, will always be at the front.
Wait a minute. Why would we focus on the slowest engineer if we're trying to build the fastest team?
That's a great question. It seems counterintuitive, I know, but the min-heap, it's kind of like a secret weapon. Trust me on this.
All right, you've got my attention. So how do we actually start using these ideas to build our dream team? Where do we even begin?
Well, the first thing we want to do is get organized. So we'll sort all our engineers by their efficiency rating, from highest to lowest.
So we're setting a baseline, right? As we move down the list, the engineer we're looking at, they kind of represent the potential bottleneck, the minimum efficiency of any team we could build from that point on.
Exactly. You're getting it. Now, with our engineers all lined up, this is where we bring in our priority queue.
Okay, I'm ready for the next step. How does this priority queue actually help us pick our team members?
So as we go down our sorted list of engineers, we're going to use our min-heap priority queue, remember that, to keep track of the K fastest engineers we've seen so far.
K being the maximum team size, right?
You got it.
Yeah.
So we're not just picking the fastest engineers overall, we're keeping track of the top K speedsters, but also considering that potential efficiency bottleneck from our sorted list.
Right. So it's like a balancing act between speed and efficiency.
Exactly. And this is where it gets exciting. Now we calculate the potential team performance.
Let's talk calculations. How do we actually figure out how well a potential team would perform?
Okay, remember how we said team performance is calculated? It's the sum of the team's speeds multiplied by the minimum efficiency.
Right.
So at each engineer on our list, we basically simulate building a team. We take the speeds of the K fastest engineers from our priority queue,
Okay.
add in the current engineer's speed,
Uh-huh.
and then multiply that whole sum by the current engineer's efficiency, which, remember, represents the potential weakest link.
It's like we're peeking into the future at each step, seeing how the current engineer would fit in with the best possible teammates we've seen so far.
Exactly. It's like a mini team building simulation within our overall algorithm.
So cool.
Yeah.
And as we move down our list, we're keeping track of the highest performance we've seen, and that'll eventually lead us to our optimal team.
You got it. Pretty neat, huh?
It is incredibly clever. By combining this sorted list and the min-heap priority queue, we're essentially scanning through tons of potential teams without having to try every single combination.
Yeah, we avoid that brute force trap.
But I have to ask, all this sorting and queue management, doesn't that come with a cost? How efficient is all of this, really?
Ah, that's where big O notation comes in handy. It's how we measure how an algorithm's performance scales as the input size grows.
Okay, so in our case, the input size would be the number of engineers. More engineers, bigger challenge.
Exactly. So the sorting part, where we arrange them by efficiency, that usually takes what we call ON log n time, where n is the number of engineers. Basically, it means as the number of engineers grows, the sorting time increases a bit faster than just linearly.
So if we double the engineers, sorting time's a bit more than double. Got it.
Perfect. Now, the priority queue operations, like inserting and removing engineers, those usually take ON log k time, k being the maximum team size.
So the size of our dream team also matters. Smaller team, less impact from the priority queue.
You got it. And here's the kicker. Even with all that, this approach is still way better than brute force. Remember, brute force gets exponentially harder as the number of engineers grows. Our method keeps things manageable.
We found something elegant and efficient. This is like finding the perfect balance between speed and quality in our code itself.
Love the analogy. And the exciting part is this can be adapted to even more complex scenarios. Remember we talked about a salary cap earlier?
Oh, yeah, like in fantasy sports, you can't just draft the best players if you go over budget.
Exactly. We'd have to tweak our approach a bit. Instead of just focusing on speed and efficiency, our priority queue would have to factor in salary too. Maybe we could come up with like a value score for each engineer that combines their performance and their salary.
So our priority queue gets even smarter, juggling multiple factors to find the best team within those constraints.
It shows how flexible this algorithmic framework can be. You can tweak it, adjust it to solve lots of real-world problems.
This deep dive has been amazing.
Uh-huh.
We went from what seemed like a really tough challenge, building this perfect coding team,
Right.
to a really clever and efficient solution. And we even figured out how to handle extra real-world stuff like salary limits. What a journey.
And hopefully it's inspired our listeners to see that algorithms, they're not just abstract concepts. They can solve real-world problems, from software development to, well, even picking your dessert at a buffet.
And on that note, we're going to take a quick break. When we come back, we'll dive into some more of the nuances of this problem and explore how we can really optimize our approach. Stay tuned.
Sounds good. It really highlights the flexibility and adaptability of this algorithmic framework. You can tweak it, adjust it, and mold it to fit a wide range of real-world optimization problems.
This episode has been a real eye-opener. We've gone from a seemingly daunting challenge building the perfect coding team to a surprisingly elegant and efficient solution. And we've even explored how to adapt this approach to handle additional real-world constraints. What a journey.
And hopefully we've inspired our listeners to see the power and beauty of algorithms. They're not just abstract concepts confined to textbooks. They're tools for tackling real-world problems, from optimizing software development to building winning sports teams, and even, dare I say, navigating that overwhelming dessert buffet.
It's amazing to see how something that started as a pretty specific coding challenge has opened up a whole world of possibilities and got us thinking about the broader applications of algorithms in solving real-world problems.
What's particularly interesting to me is how this weakest link concept goes beyond just coding. Think about it. In any team-based endeavor, whether it's a sports team, a musical ensemble, or even a group of friends tackling a DIY project, the overall performance is often limited by the least capable member.
You're absolutely right. It's a reminder that balance and synergy are crucial. Sometimes a group of solid performers who collaborate well can outperform a team with a few superstars but poor communication.
Precisely. And that brings us to an important question. Can we truly capture the essence of teamwork with just numbers and algorithms? How do we account for those intangible qualities that make a team truly exceptional? Things like communication skills, creativity, adaptability, and the ability to handle pressure.
That's a question that's been on my mind throughout this deep dive. Our algorithm is great at crunching numbers and finding the optimal combination based on measurable metrics like speed and efficiency. But can it really tell us everything we need to know about building a truly high-performing team?
That's where things get really interesting. While algorithms are incredibly powerful tools for optimization, they do have limitations. They excel at handling quantifiable data. But when it comes to those more nuanced human aspects of teamwork, we need to look beyond just the numbers.
So it's not just about finding the right algorithm. It's about understanding the context, the specific challenges we're facing, and the unique strengths and weaknesses of each individual on the team.
Absolutely. Algorithms can provide valuable insights and guide our decision-making, but they shouldn't be the sole determinant. Ultimately, building a successful team requires a blend of data-driven analysis and good old-fashioned human judgment.
That's a great point to end on. It's a reminder that while we strive for efficiency and optimization in our code and in our teams, we should never lose sight of the human element. It's that spark of creativity, that ability to connect and collaborate, that truly elevates a team from good to exceptional.
Well said. And with that thought, I think we've reached the end of our deep dive into maximizing team performance. We've explored the problem, dissected the algorithm, and even pondered the broader philosophical implications. Hopefully, we've inspired our listeners to think critically about how algorithms can be used to solve real-world problems while always remembering the importance of the human touch.
Thank you so much for joining us on this episode of AI.Code.Cast. We hope you've learned something new and maybe even sparked some ideas for your own coding adventures.
Until next time, happy coding.
So it seems like we can't always rely solely on algorithms, especially when dealing with the human side of things.
You're absolutely right. When it comes to those less tangible aspects of teamwork, like communication or creative problem solving, algorithms might fall short. They're amazing at handling data and numbers.
Yeah.
But those softer skills, those are harder to quantify.
It makes you wonder if there's a way to, incorporate those human elements into our algorithms,
Yeah.
maybe make them even smarter and more effective.
That's a really interesting thought, and honestly, it's something researchers are actively exploring. There's a whole field dedicated to, understanding and modeling human behavior in AI systems.
So we could potentially teach AI to recognize and value things like good communication, adaptability, all those things that make a team truly click.
Exactly. It's a complex challenge, but the potential is huge. Imagine having AI tools that could help us build teams optimized not just for speed and efficiency,
Right.
but also for things like creativity, resilience, even morale.
That would be game-changing. It would revolutionize the way we approach teamwork, not just in software development, but in all sorts of fields.
Absolutely. It's about finding that sweet spot, that balance between the power of data-driven algorithms and the irreplaceable value of human intuition and experience.
It sounds like the future of teamwork is going to be a fascinating blend of human and artificial intelligence, each playing to its strengths.
I couldn't agree more. And who knows, maybe one day we'll have AI that can even help us resolve conflicts and boost team spirit.
Now that's an AI I'd love to have on my team.
Well, on that note, I think it's time to wrap up our deep dive into maximizing team performance.
Yes, we've covered a lot of ground today. We started with this seemingly simple coding challenge, and it led us to some pretty deep insights about teamwork, algorithms, and even the future of collaboration.
It just goes to show that sometimes the most interesting journeys start with a single line of code.
Absolutely. A huge thank you to our listeners for joining us on AI.Code.Cast. We hope you enjoyed this deep dive as much as we did.
And until next time, keep coding, keep learning, and keep building amazing teams.